so can you tell me about yourself, like what you're doing and
My
would
major
be,
and all that.
yeah, yeah.
I'm doing civil engineering in my university. I'm in my
Okay,
third year currently.
okay, okay, okay. So you need to discuss about mechanics, engineering mechanics, right?
What?
You want to discuss engineering mechanics.
This I'm do physics is what I want to do. I'm taking physics 2 this semester.
Okay, okay. You're taking physics too.
The syllabus is not there, but it's coming tomorrow. I'm gonna send it to you when it comes out because of some technical stuff on the school's end.
Okay, okay. So, okay. Have you tried doing this syllabus, your physics too?
Um, it's coming. It's coming. Today's Thursday, right? It should be. Yeah, today's Thursday. It's coming tomorrow.
Okay, it's coming tomorrow. Okay. Any idea about syllabus? Like what you have? What
Let's see.
I think someone shared a seat, right? Let me check. I hope it was from your side.
We might be learning about electrostatics. I think we're gonna learn about that first.
Okay, sure. Yeah, that would be better, right?
I looked on my lab. I have labs starting next week. That's I think since the lab's gonna be covering that, I'm going to assume that this is the first thing we're gonna be learning.
Okay, yeah, that's great. Okay, electrostatics is like a very good topic. These days everything is working based on this model, right? How we interact with the charges, the electrons, protons, and all, right? And
Yeah.
they are very honest and obedient about this civilization. Clear? The charges are doing everything for us, right?
Yeah.
Even we are interacting this time because of the charges, right? Because they are moving. And
Yeah.
so now we will discuss like what is the basic behind it and how it is going to help you in your syllabus, right? And how it is why it is important to understand and why every engineer need to know about it, right? So can you tell me something about electrons?
Yeah. So electrons are negatively charged, basically.
Good,
Good,
that's
that's
great.
great.
And
And
what is
what is
the
the
amount of
amount of
charge
charge
on
on
a
a
single
single
electron?
electron?
It's like minus. No. Is that what you're asking?
Yeah,
Yeah,
yeah.
yeah.
I'm
I'm
talking
talking
about the
about the
value of
value
that.
of that.
Okay, no
Okay, no
issue.
issue.
Okay.
Okay.
Do you
Do
have
you have
idea
idea
about
about
atomic
atomic
structure?
structure?
I think I don't know. I'm not sure if I'm gonna word this correctly.
Okay.
Okay.
I think an atomic structure would be um, well, it's a structure, obviously. No, I'm not gonna
Yeah.
say.
Okay.
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 We
We
will
will
go with
go
very
with very
basic
basic
model,
model,
right?
right?
So
So
basically, what
basically, what
happened?
happened?
Oh yeah, it's based on yeah, it's based, isn't it based on the amount of neutrons, protons, electrons a
Good.
certain.
That's
Yeah,
yeah.
that's
That's
great.
great.
So,
Yeah.
so
So
basically,
basically,
atomic
atomic
structure is
structure is
all
all
about
about
a
a
structure of
structure
an
of an
atom,
atom,
right?
right?
And
And
these
these
atoms are
atoms are
structured
structured
by
by
using
using
three
three
different
different
basic
basic
particles
particles
that are
that are
electron,
electron,
proton, and
proton, and
neutron,
neutron,
right?
right?
Yeah.
And
And
proton and
proton and
neutron,
neutron,
they are
they are
basically
basically
into
into
the
the
center
center
of
of
the
the
atom,
atom,
right?
right?
That
That
term is
term is
known as
known as
nucleus.
nucleus.
Clear?
Clear?
And
And
electron
electron
moves
moves
around that
around that
nucleus.
nucleus.
Okay?
Okay?
Let
Let
me
me
share the
share the
screen with
screen with
you.
you.
Of course.
In
In
which
which
university you
university you
are?
are?
In industry,
University.
University.
Which
Which
university?
university?
it's called UMass Dartmouth.
Okay,
Okay,
like
like
Okay.
in US?
Let me type it in. If I, where is there a chat? I can. There should be.
right?
right?
It's called UMass Dartmouth.
UMass
UMass
Dermot.
Dermip.
In
In
which
which
country it
country it
is?
is?
It's in America
Okay.
in the
Okay.
state of Massachusetts.
Oh,
Oh,
Massachusetts.
Massachusetts.
Okay.
Yeah.
Okay.
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 Yeah, you
Yeah, you
can
can
send me
send
the
me the
details,
details,
right,
right,
about
about
your
your
university and
university and
all,
all,
because
because
I
I
have a
have
lot
a
of
lot of
students
students
from
from
different
different
universities
universities
in
in
US.
US.
One of
One
my
of my
students is
students is
from
from
NC
NC
State,
State,
and
and
one
one
another
another
student
student
is
is
from
from
the
the
university. I'm
university. I'm
forgetting the
forgetting
name.
the name.
University of
University of
State
State
University of
University of
Arizona.
Arizona.
So
So
I
I
have
have
students
students
from
from
US,
US,
a lot
a
of
lot of
other
other
students
students
also.
also.
So,
So,
but
but
the
the
universities in
universities in
US,
US,
right?
right?
Everything
Everything
depends
depends
on.
on.
Hello,
Hello,
am I
am I
audible?
audible?
Yeah, you're good. I can hear you all right.
Okay.
Okay.
So
So
actually,
actually,
what I
what I
was
was
talking
talking
about
about
the
about the
syllabus,
syllabus,
right?
right?
The
The
syllabus
syllabus
basically are
basically are
designed by
designed by
your
your
professors,
professors,
right?
right?
Yeah.
So every
Every
university
university
have
have
bit
bit
different
different
kind of
kind of
syllabus, right?
syllabus, right?
Yeah.
No, yeah, that's
Yeah,
yeah,
that's
that's
why
why
I
I
just
just
need
need
to
to
see the
see the
syllabus,
syllabus,
right? You
right?
can
You can
send
send
me
me
after the
after the
class,
class,
okay?
okay?
But
But they haven't. The thing is, they haven't. There's some technical stuff that we switched to a new platform to access our assignments or whatnot. Because last year
okay,
we used something different, and there's been some technical stuff going on transferring that, and my professor is telling me that the syllabus is coming tomorrow, the Friday, basically tomorrow.
okay,
Okay.
okay,
Okay.
no
No, no
issue.
issue.
Okay, you
Okay, you
can
can
share
share
me
me
Yeah.
up to
up to
tomorrow.
tomorrow.
So
So
basically,
basically,
because
because while
teaching
teaching
the
the
students
students
from
from
US
US
universities,
universities,
I
I
always
always
take
take
care
care
that
that
in
in
which
which
university they
university they
are,
are
and
and
and how their
how their
professor
professor
designed the
designed the
syllabus,
syllabus,
right?
right?
Because
Because
if
if
I'm
I'm
going in
going
a
in a
very
very
generic
generic
way,
way,
and
and
sometimes
sometimes
your
your
professors
professors
don't
don't
want
want
that,
that,
right?
right?
Yeah.
Yeah,
Yeah,
that's
that's
why
why
you can
you can
share me
say me
that.
that.
But
But
today we
today
will
we will
discuss
discuss
some
some
of the
of the
very
very
basic
basic
things
things
about
about
electrostatics,
electrostatics,
and
and
that is
that is
going to
going to
help
help
you
you
to
to
understand.
understand.
It
It
will
will
help you
help
to
you to
visualize the
visualize the
things,
things,
right?
right?
How
How
things
things
are
are
designed.
designed.
Okay,
Okay,
so
so
I'll
I'll
start with
start with
this
this
one.
one.
Can you
Can
see
you
the
see the
screen?
screen?
Yeah, I can see it.
Okay,
That's great.
that's great.
So
So
basically,
basically,
I
I
have
have
this is
this is
structure.
structure.
This
This
is
is
nucleus.
nucleus.
You know,
You know,
Yeah.
I
I
hope
hope
you may
you may
have
have
idea
idea
about
about
nucleus.
nucleus.
And
And
Yeah.
it
it
have
have
two
two
different
different
basic
basic
particles.
particles.
First one
First
is
one is
proton,
proton,
and the
and the
second one
second one
is
is
neutron.
neutron.
Neutron. Yeah.
Neutron.
Neutron.
The
The
thing that
thing that
I
I
want to
want to
especially
especially
uh, take
take
into your
into your
notice
notice
is
is
electrons are
electrons are
always
always
moving
moving
around
around
the
the
nucleus.
nucleus.
Okay,
Okay,
Mm-hmm.
okay.
okay.
So
So
actually, what
actually, what
happens?
happens?
This is
This is
positive
positive
charge.
charge.
Proton have
Proton have
positive
positive
charge,
charge,
and the
and the
amount of
amount
that
of that
charge is
charge is
1.6
1.6
multiplied by
multiplied by
10 to
10
power
to power
minus
minus
19
19
coulombs.
coulombs.
Okay,
Okay,
Uh-huh.
and
and
electrons
electrons
have
have
charge
charge
minus
minus
1.6
1.6
into
into
10 to
10
power
to power
minus
minus
19
19
coulombs,
coulomb,
right?
right?
Uh-huh.
This is
This
the
is the
basic
basic
unit of
unit of
charge,
charge,
right? The
right? The
smallest
smallest
possible
possible
unit of
unit of
charge
charge
that
that
is
is
available
available
and
and
about
about
which we
which we
have
have
idea,
idea,
right?
right?
How
How
these
these
electrons are
electrons are
getting
getting
charged,
charged,
we
we
don't have
don't
any
have any
idea, right?
idea, right?
What is
What is
Yeah.
charge?
charge?
We
We
can't
can't
claim
claim
anything
anything
about
about
charge.
charge,
Okay,
okay?
the
The
thing
thing
that we
that we
are
are
discussing,
discussing,
actually
actually
in
in
science, when
science,
we
when we
study
study
something,
something,
right?
right?
What do we
What we
study?
study?
We
We
study
study
like
like
what
what
and
and
sorry,
sorry,
we
we
study
study
what?
what?
Suppose
Suppose
I'm
I'm
talking
talking
about
about
charges.
charges,
Okay,
okay?
so
So
what we
what
will
we will
discuss.
discuss,
First
first
thing
thing
that we
that
will
we will
discuss
discuss
is
is
what is
what is
charge.
charge,
Clear?
clear?
Mm-hmm.
And what
And
are
what
the
are the
effects of
effects
the
of the
charge?
charge,
Effects of
effects
the
of the
charge.
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 But
But
actually, we
actually, we
don't
don't
have
have
that much
that much
idea
idea
about
about
charges,
charges,
right?
right?
What are
What are
charges?
charges,
How they
how they
got
got
developed,
developed,
right?
right?
what is the
Yeah.
meaning of it? We don't have. We have just very simple informations that electron carries this amount of charge, right? And a proton carry this amount of charge. Okay? We don't have any other information about charges. Clear? But we have a lot of different things about effect of charges. Okay? So in your syllabus, when we are talking about electrostatistics, right? What is the meaning of this? Means we are talking about an electron, a charge that is stable. Okay?
Mm-hmm.
So we will discuss about stable charges. Okay? Is that clear?
Yeah.
Good. Now we will do something about charges, right? Suppose I have an object, clear? And I'm saying this is having 10 coulomb of charge. Okay?
Mm-hmm.
Plus 10 coulomb of charge. So first of all, we need to understand like how we can develop charge on an object. Okay? Because
Mm-hmm.
you know every object is made by atoms. Every object is made by atoms.
Atoms.
Right? This is the atom. And every atom have electrons on its boundary. Okay?
Mm-hmm.
So suppose this atom have an atomic structure like this. Atomic arrangement like this. Okay? So every atom have electrons and proton into it. Okay?
Mm-hmm.
As per Dalton's idea, and other scientists also discussed about it, that the basic nature of an atom is always neutral. Basic nature is always neutral.
Mm-hmm.
Yeah? We had neutrons also. Neutrons have always zero charge. What charge?
Yeah.
Zero charge. They are neutral. Okay? But the overall arrangement of an atom is always neutral. What does it mean? It means that they have equal amount of positive and negative charge. They have equal amount of
Electrons and electrons and protons, basically.
yeah. That's always that would be always equal to each other, right? Why? Because if they are equal, suppose it have n electrons, what would be the total amount of charge on n electrons? That would be this one. No. That would be n multiplied by minus 1.6 multiplied 10 to the power minus 19, right?
Yeah.
This is negative. And what would be the number of amount of charge on a proton? That is going to be this one. Okay?
Mm-hmm.
And they will get cancelled out. Okay? What does it mean? If there are equal amount of neutron, electron and proton, the total sum would be 0, right?
Yeah.
So basically an atom would be neutral. So simply you may be wondering like what is the use of these informations? Okay? First of all, we will try to understand how we can develop charge on an object. Okay? Suppose this is an object and I'm taking an atom from it. Okay? This atom have electrons on the boundary and neutron, proton on the center. Clear?
Yeah. Mm-hmm.
So if I'm applying any amount of energy or any kind of disturbance, what will happen? This electron will come out of the atom, right? We can do this thing by 3 different methods. Okay? What methods we will discuss about them. Okay? But first of all, what we need to understand is electrons will come out if I'm applying any amount of energy on the atom.
Mm-hmm.
Is it clear?
Mm-hmm.
Good. And by applying energy, I will remove electron. Suppose this was having 10 electrons and 10 protons. Okay? And by applying some amount of energy, what will happen? I can remove one electron. So how many electrons now I
It
will
would be
have?
9 electrons and 10
Good.
protons.
Protons would be always same because removing a proton is very tough. Okay? So proton is 10. So what would be the total nature of the net nature of this atom? The net nature would be positive. Clear?
Mm-hmm.
Net would be positive. The effective charge on the atom would be positive. Clear? And if I'll ask you what would be the amount of charge, what would be the amount of positive charge. So that would be the difference between these two. Clear? What is the difference? Difference is 1. Clear?
Yeah.
Now the amount of positive charge would be 1 multiplied by 1.6 into 10 to the power minus 19 coulomb. Right?
Mm-hmm.
Suppose I'm removing 2 electrons. 2 electrons removed. In that case, what would be the charge on an object? That would be 2 multiplied by 1.6, clear? Into 10 to the power minus 19. Okay? Is it clear?
Yes.
Good. So simply, the amount of electrons we are removing from an atom, right? Multiplied by 1.6 into 10 to the power minus 19 would be the net positive charge on that atom, right?
Mm-hmm.
Is it clear or not?
Clear.
Good. And what, like, I can also put some electron on the atom also, right? We can increase the number of electrons, okay? By adding electrons into it. What will happen in that case? The number of electrons would be more than the number of protons, okay? So the net charge would be negative. Net charge would be negative. Clear? But one more thing that we can notice is every time I will get any integer multiple of 1.6 into 10 to the power minus 19. Clear? Why? Because we can remove integer number of electrons. We can't remove half electron from anything, right? We can't remove 1.5 electrons,
Uh-huh.
right? Because electrons are like, we don't have any exact idea about the size of electrons, clear? And we can say that we don't have idea that if electrons can be divisible or not, right? So electrons are not divisible. So what we need to keep in mind that every time I'm talking about a charge, that would be always integer multiple of 1.6 into 10 to the power minus 19. Clear?
Mm-hmm.
Is it clear?
Clear.
Yeah, I hope you know about integers.
Integrals, you mean?
Yeah, that 1, 2, 3, 4, 5, right?
Yeah.
Okay, that's great. So this is all about charging, like how you can develop charge. Okay, so basically charging in an classical physics. I'm not talking about quantum physics, right? In quantum things are totally different. But in classical physics, charging means removing an electron, or adding electron. Okay?
Yeah.
If you are adding electron, that would be negative, and if you are removing electron, that will make it positive. I hope it's very clear.
Clear.
Good. Now the topic that we are discussing is electrostatics, right?
Mm-hmm.
Okay. What is electrostatics? Like in this case, suppose I have an object, clear? And this object have q amount of charge, clear?
Mm-hmm.
What it will do, if this charge is stable, this charge can be either stable, okay?
Mm-hmm.
Or you can find this charge as moving, okay? Is it clear?
Clear.
If we are talking about stable charge, if charge is not moving, if charge is stable, it will develop what? It will develop electrostatic field.
Mm-hmm.
What it will develop? It will develop electrostatic field.
Field.
Good. And if there are two different charges, okay, in that case, what will happen? This will develop a field, and this will also develop a field. Clear?
Mm-hmm. Yeah.
If there are, you need to understand something about the forces. Clear? Forces are always result of interaction of two different things. Clear?
Mm-hmm. Clear.
Two different fields. Clear? If talking about field forces. Okay? So it is about to develop it will develop a electrostatic force. Electrostatic force. Clear? And this electrostatic force would be result of
two different electrostatic fields.
Clear?
Clear?
Mm-hmm.
One more
One more
thing,
thing,
when
when
charges are
charges are
moving,
moving,
in
in
that
that
case, they
case,
will
they will
develop
develop
magnetic
magnetic
field.
field.
They will
They will
develop
develop
magnetic
magnetic
Magnetic field.
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 And
And
this
this
two
two
different
different
fields
fields
will
will
develop
develop
what?
what?
Force.
Force.
Magnetic
Magnetic
Mm-hmm.
force.
force.
Clear?
Clear?
Mm-hmm.
Magnetic
Magnetic
force.
force.
Okay?
Okay?
So you
So you
can
can
see
see
this
this
electrostatic
electrostatic
force you
force you
will
will get
by
by
which?
which?
By
By
two
two
fields.
fields.
Clear?
Clear?
Two
Two
fields.
fields.
Electrostatic
Electrostatic
field.
field.
This you
This
will
you will
get
get
by
by
two
two
magnetic
magnetic
fields.
fields.
Clear?
Clear?
In
In
that
that
case, you
case,
will
you
get
will get
magnetic
magnetic
force.
force.
Is it
Is it
clear?
clear?
But
But
Okay.
suppose
suppose
I'm
I'm
interacting an
interacting an
electrostatic
electrostatic
field
field
and a
and a
magnetic
magnetic
field.
field.
What I
What
will
I will
get?
get?
I
I
will
will
get
get sorry,
magnetic.
magnetic field.
The
The
combination of
combination of
two
two
electrostatic
electrostatic
field will
field will
develop
develop
electrostatic
electrostatic
force.
force.
Okay,
Okay,
the
the
interaction of
interaction
two
of two
magnetic
magnetic
field will
field will
develop
develop a
magnetic
magnetic
force.
force.
But
But
interaction
interaction
of an
of an
electromagnetic
electromagnetic
field
field
and
and
magnetic
magnetic
field
field
will
will
develop electrostatic
electrostatic
field and
field and
magnetic
magnetic
field will
field will
develop
develop
what?
what?
Electromagnetic
Electromagnetic
wave.
wave.
Mm-hmm.
Electromagnetic
Electromagnetic
Field.
wave.
wave.
Clear?
Clear?
Mm-hmm.
So
So
in
in
the
the
topic
topic
electrostatistics,
electrostatistics,
statics,
statistics,
we
we
are
are
going to
going to
discuss
discuss
what?
what?
About
About
stable
stable
charges.
charges.
Okay?
Okay?
Mm-hmm.
And
And
we will
we will
also see
also see
the
the
syllabus
syllabus
by
by
after
after
tomorrow,
tomorrow,
right?
right?
And we
And we
can
can
plan
Yeah.
plan
accordingly.
accordingly.
Okay?
Okay?
But
But
now
now
I
I
hope you
hope you
have
have
studied
studied
these
these
things in
things in
your
your
HSC,
HSC,
right?
right?
Uh-huh.
You was
From
from
IBDP or
IBDP or
IGCSE?
IGCSE
In your
in your
10
10
plus
plus
2?
2.
Hello.
Hello.
What?
In your
In your
schooling,
schooling,
in
in
which
which
board you
board you
was?
was?
In
IBDP.
which?
In which
In which
syllabus,
syllabus,
right?
right?
IBDP,
IBDP, like
there are
there are
different
different
kind of
kind of
boards,
boards,
right?
right?
IBDP,
IBDP,
I'm
IGCSE.
IGCSE.
not too sure. I'll send you and I'll let you and you probably should know right away.
Okay,
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 no
no
issue.
issue.
Okay,
Okay,
okay.
okay.
I was
I was
talking
talking
about your
about your
background.
background.
The
The
uh, when you
when you
was in
was
your
in your
schooling,
schooling,
okay?
okay?
Because
Because
every
every
different
different
board
board
have
have
different kind
different
of
kind of
syllabus,
syllabus,
okay?
okay?
So
So
I
I
just
just
want to
want to
understand like
understand like
from
from
which
which
syllabus or
syllabus or
which
which
board
board
you have
you have
completed
completed
your
your
10
10
plus
plus
2 or
2 or
SSC,
SSC,
HSC, a
HSC, a
lot of
lot of
different
different things
people
people
say.
say.
Okay,
Okay,
Mhm.
no
no
issue.
issue.
Okay,
Okay,
so
so
now
now
we are
we are
going to
going to
discuss
discuss
about
about
electrostatic
electrostatic
field.
field.
Electrostatic
Mhm.
Electrostatic
field.
field.
Okay,
Okay,
do you
do you
have
have
any
any
idea
idea
about
about
electrostatic
electrostatic
field,
field,
the
the
value of
value
it,
of it,
and
and
how it
how it
is
is,
how it
how
will
it will
change
change
the
the
atmosphere
atmosphere
around it,
around it,
what
what
effect it
effect
will
it
do
will do
on the
on the
surrounding
surrounding
about it?
about it.
Do you
Do
have
you
any
have any
idea?
idea?
Uh, um, can you repeat your question?
Yeah.
Yeah.
Do you
Do you
have
have
any
any
idea
idea
about
about
electrostatic
electrostatic
field?
field?
What is
What
the
is the
formula?
formula?
What is the
What is the
definition
definition
and
and
all?
all?
I don't have an idea.
Okay.
Okay,
No
no
issue.
issue,
Right?
right?
Don't worry.
Don't worry.
So
So
I
I
have a
have a
charge
charge
here.
here,
Clear?
clear?
Mm-hmm.
And
And
what will
what will
happen?
happen?
This
This
charge is
charge is
going to
going to
develop
develop
an
an
electrostatic
electrostatic
field
field
around it.
around it,
Electrostatic
electrostatic
field
field
around
around
it.
it.
Clear?
Clear?
Uh-huh.
So we
So
will
we
Oh,
will.
okay. I think I'm starting to understand or recall.
okay.
Okay,
Sure.
sure.
So I think we have like a that's the nucleus, right? Or,
Not
Not
nucleus.
nucleus.
Nucleus is
Nucleus is
something
something
different.
different.
Nucleus
Nucleus
is
is
the
the
place
place
where
where
protons or
protons or
neutrons
neutrons
are
are
there,
there,
right?
right?
I'm
I'm
talking
talking
about
about
something
something
that
that
if
if
I
I
have a
have a
charge
charge
Q,
Q,
oh, it means like it remains stationary, like
yeah,
yeah,
if
for
there
a
is a
especially
period.
charge
charge
Q,
Q,
if I'll ask you what would be the field,
Okay.
okay?
I
I
was
was
talking
talking
about
about
electrostatic
electrostatic
field, right?
field, right?
Yeah.
What would be the amount of or the intensity of the field at a distance r developed by a charge q?
Wouldn't like R stay the same basically? Since
Okay, now let me tell you. Okay, so actually, if I have a charge, okay, what this charge will do, then this will start a disturbance in surrounding. It will start a disturbance in surrounding. Clear?
okay. Yeah.
And that disturbance can be experienced or measured only if we will apply, we will develop another same kind of disturbance. Okay,
Yeah.
in like how these electronic systems work, right? Our telephone and other things, our
Yeah.
mobile, they work on radio waves, right?
Mhm.
We know that we have radio waves in our surrounding. Clear?
Yeah.
To identify them, to experience them, what we need, I need a device that can identify, that can receive radio waves. Clear? In same pattern, if I have a charge in surrounding, what it will do, it will start disturbing its surrounding. Okay? But
Mhm.
you can't experience that disturbance uh, in a simple pattern, right? In simple
Mhm.
manner. For that, you will have to put another charge. Clear?
Mhm.
If you will
Yeah.
put another charge, what you will see that that charge is getting a disturbance. Okay? Based on that, you can say that there is a field here. Okay?
Mhm.
So there was one scientist, Coulombs. You know about him?
Can you repeat coulomb?
Yeah, Coulombs.
Oh, columns.
Yeah.
Well, okay. Doesn't describe Coulomb's law just doesn't
Good,
describe electrostatic force between two charges.
good, 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 good. Yeah, he talked about force between two charges, right? He
Mhm.
also discussed about the electrostatic field by a charge in surrounding. Clear?
Yeah.
So, Coulombs told us that the intensity of field developed by a charge will depend on the amount of charge you are putting here, right?
Mhm.
It will also depend on what? It will also depend on 1 over r square, where r is the distance from the charge. Okay?
Mhm. Yeah.
So amount of electrostatic field will depend on two things. One is what amount of charge you have, clear? And the
Yeah.
other thing would be what is the distance of that charge from a given point. If I'm saying that I want to find the field at point P, or at a point A, clear? So for that, we will have to identify how far A is at what is the distance between A and the charge Q. Okay? So the amount of field is going to depend on these two things. Clear? If you
Uh-huh.
have more charge, if you have high amount of charge, clear? In
Yeah.
that case, the field would be higher or
Mhm.
stronger. Clear?
Yeah.
And if you have weak and if you are trying to find field at a distance r, clear?
Mhm.
Field will depend on this r also. Clear?
Mhm.
So if you are trying to find the field like at a very far distance from the q, you will find that the intensity of the field is very low. Clear? The
Mhm.
effect of the field is very low. So effect of the field is depending on what? Is depending on the amount of charge and the
Mhm.
clear.
Yeah.
And also there is another factor, because suppose you have charge here, clear, but
Mhm.
this charge is doing what? It's trying to disturb the molecules here. Okay? If I'm saying that we have what? We have air here, clear?
Mhm.
Air contains what? Air contains N2, O2, these kind of gases. Okay?
Uh-huh.
So this charge is going to disturb these gases also. Okay? The atoms
Mhm.
of these
Yeah.
gases. So
So
that's
that's
why
why
Coulomb
Coulomb
also
also
identified a
identified a
factor
factor
that is
that is
known
known
as
as
epsilon
epsilon
naught.
naught.
Clear?
Clear?
Mm-hmm.
This
Yeah.
is
This is
known
known
as
as
permittivity
permittivity
of
of
medium.
medium.
Of
Of
medium.
medium.
Clear?
Clear?
Mm-hmm.
Mhm.
So the
So the
amount
amount
of
of
electrostatic
electrostatic
field
field
is
is
going to
going to
depend
depend
on
on
what?
what?
Q
Q
over
over
r
r
square
square
Mm-hmm.
multiplied by
multiplied by
1
1
over
over
4
4
pi
pi
epsilon
epsilon
naught.
naught.
1 over
1 over
4
4
pi
pi
epsilon naught.
epsilon naught.
Clear?
Clear?
Mm-hmm. Yeah.
Yeah.
And
And
he
he
also
also
gave
gave
some
some
values
values
that
that
for
for
he
he
said
said
that
that
for
for
air
air
the
the
value
value
of
of
1
1
over
over
4
4
pi
pi
epsilon
epsilon
naught
naught
is
is
what?
what?
9
9
multiplied by
multiplied by
10 to
10 to
power
power
10 to
10 to
power
power
plus
plus
9.
9.
Clear?
Clear?
Mm-hmm. Yeah.
Yeah.
What is
What is
the
the
value of
value
1
of
over
1 over
4
4
pi
pi
for
for
the
the
air?
air?
That would
That
be
would be
9
9
into 10
into
to
10 to
power
power
9.
9.
Is
Is
it
Yeah.
it
clear?
clear?
I
I
hope
hope
it's
Yeah.
it's
clear.
clear.
Yeah.
Yeah.
One more
One more
thing.
thing.
There is
There is
an
an
like
like
you
you
can
can
say
say
that
that
convention
convention
that
that
the
the
direction of
direction of
electric
electric
field
field
would be
would be
always
always
away
away
from
from
positive
positive
charge.
charge.
Clear?
Clear?
Mm-hmm.
And
And
if
if
charge is
charge is
negative,
negative,
it would
it
be
would be
towards the
towards the
negative
negative
charge.
charge.
Clear?
Clear?
Yeah.
Yeah.
So if
So if
I'm
I'm
asking
asking
you
you
to
to
find the
find the
direction of
direction of
field at
field at
A,
A,
for
for
that you
that
will
you
have
will
to
have to
check
check
if
if
Q
Q
is
is
positive or
positive or
negative.
negative.
Clear?
Clear?
If it
If
is
it
Yeah.
is
positive,
positive,
the
the
direction
direction
of the
of the
electric
electric
field would
field would
be
be
in the
in the
direction
direction
away
away
from
from
this
this
charge.
charge.
Okay?
Okay?
Yeah.
Yeah.
And
And
if this
if
is
this is
negative
negative
and you are
and you are
trying to
trying to
find the
find the
field at
field at
A,
A,
the
the
amount of
amount of
field would
field
be
would be
exactly
exactly
same,
same,
right?
right?
But
But
Mm-hmm.
the
the
direction
direction
of
of
field would
field would
be
be
what?
what?
This would
This
be
would be
into
into
this
this
direction.
direction.
Clear?
Clear?
Towards the
Towards the
Yeah.
charge.
charge.
I hope
I
it's
hope it's
clear.
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 Good.
Good.
Now the
Now the
thing
thing
is,
is,
we
we
need
need
to
to
check
check
some
some
examples,
examples,
right?
right?
Yeah.
Yeah.
I
I
think
think
that
that
would
would
be
be
better to
better to
understand.
understand. That
That will
will
help us
help us
to
to
understand it
understand it
Yeah.
better.
better.
Clear?
Clear?
Yeah.
So
So
suppose
suppose
I
I
have a
have a
charge
charge
Q.
Q.
The
The
amount of
amount of
charge
charge
is
is
given is 1 multiplied by 10 to power minus 10 coulombs. Okay? And distance is what?
Mm-hmm.
1 nanometer. Clear?
Clear.
And the charge is available in air. In air. Clear?
Yeah.
So I'm saying that medium is air. So this is the charge. Suppose this is the charge, and it is into a medium of air. Clear? And
Yeah.
we want you to like, sorry, just a minute. If I'll ask you what would be the field at distance 1 nanometer, clear,
Uh-huh.
by a charge 1 into 10 to power minus 10 coulomb at point A, clear?
Mm-hmm.
Can you find the amount of field?
So would we use 1/4 to the pi theta for this one also?
Good, good. Same. Everything would be same like this. Okay?
Mm-hmm.
Because we are talking about finding electrostatic field. Okay?
Mm-hmm. So I would use 9 times 10 to the power of 9, and then do I subtract that by 1 times 10 to the negative 10?
Yeah, let me solve it for you, right? And
I
this is
think I I think I'm not, I
what?
got half, but think I got the gist of it, sort of.
Hello.
Yeah, I hear you.
Yeah. Sorry, you're not audible. Okay, can you solve it? Can you find the value?
Okay, so obviously this would be it would be the same. It would be 1/4 pi. What did you call the thing again? Is it theta
Epsilon. Epsilon.
epsilon? Epsilon.
Epsilon.
Okay, and then that would equal to, did I say 9 times 10?
9 times 10 to the power 9.
Mm-hmm.
9 multiplied by 10 power 9.
So we would we take that and divide it by 1 times?
No, no, this is the value of this one. Clear? So by
Yeah.
replacing this one, you can replace it by 9 multiplied by 10 to the power 9.
Okay.
Okay?
Mm-hmm.
Can you try that?
Okay. I think I did it. So basically, I would, for the numerator, I would put 1 times 10 to the power of negative 10, and then over that same equation squared in the denominator,
Good, good.
and then numerator denominator would be 1 times 10 to the power of negative 10 over 1 times 10 to the power of negative 18. Then for that fraction, I basically bring the denominator up. That gives me 10 to the 1 times 10 to the power of 8. Then with 9 times 10 to the power of 9, to powers add, and that gives you 9 times 10 to the power of 17.
Good. 9 into 10 to the power 70.
17.
Clear?
Mm-hmm.
newtons. Newtons over coulomb, right? This would be
Yeah.
the charge, the field, electricity field. That's
Mm-hmm.
great. Okay, so this is like basic thing, clear? They can
Sure.
ask you what would be the amount of field. In other words, they usually say that what would be the intensity of field,
Mhm. Uh-huh.
but they will ask intensity of the field. Clear? So in both the cases, this would be your answer, right?
Yeah.
But we have discussed that every field have a given set of direction, right?
Mm-hmm.
This charge is having field in this direction, clear? And
Mm-hmm.
this charge is having field into this direction, clear?
Mm-hmm.
So what kind of problems they are going to ask you, right?
Mm-hmm.
They will not ask you like what there is a charge and there is a field, clear, or there is
Mm-hmm.
distance, and
Yeah.
they're not going to ask you these things directly. Okay, the
Yeah.
first kind of problems that they usually ask is when there is superposition of two different fields, clear.
Mm-hmm.
If I'll ask you, I have a charge here 1 multiplied by 10 to power minus 6 coulombs, right? I have
Mm-hmm.
another charge 2 multiplied by 10 to power minus 6 coulomb, and and there is a point P, clear?
Yeah.
And this point is 5 mm away from this charge. Suppose I'm saying this charge is Q1 and this charge is Q2, right?
Mm-hmm.
And this is 10 mm away from this point is 10 mm away from this charge, clear?
Yeah.
I'll ask you like what would be the net field on the point P, net field on point P,
Yeah.
clear? What
Mm-hmm.
does it means? That what would be the combined effect of Q1 and Q2 at point P? Okay,
Mm-hmm.
how can you solve this one?
When I could just do 9 times 10 to the power of 9, multiply that. Do them separately first, and then I would just like add
Good,
them together. Would you do that?
good. You will have to add them, right? But
Yeah.
before adding, because these things are vector in their nature, right?
Mhm. Yeah.
You must be having idea about vector quantities. That vector quantities always comes with a direction, okay?
Mhm.
And if two things are into a single direction,
Mhm.
only in that case you can add them, right? If they
Yeah.
are opposite in direction, what you will have to do, you will have to subtract them, isn't it?
Yeah.
Good. So yeah, you will have to identify what would be the direction of electric field on P due to Q1, and what would be the direction of electric field on P due to Q2, right?
Hmm.
Can you find?
I can try. Yeah.
Yeah, let's try that.
I kind of need help on this.
Okay, no issue, right?
I
So
did the I did the So basically, what I did so far, I did the 9 times 10 to the power of 9, and then just I did the little thing. I got 18 times 10 to the power of 15. Um, I
for
was just
what? For this one, for
uh,
Q1.
for yeah, for Q1, I just did that.
Okay, for Q1,
They,
you are
they both are they both are the same. So I
mm,
does that say 1 times 10?
no, no, no. This is like 10 mm, right? And this is
No, I'm
5
talking
mm.
about under the Q under one of the Qs under Q1. Does that say 1 times 10?
1 times 10 power minus 6, right?
Okay. I found this. I found Q2. Okay, I think
No, no, that's one.
y- your writing confused me for a minute. That's
Okay, okay. Let me clear it.
yeah.
Okay, okay. You can ask, right? Sometimes
y-
I do write very fast, and I hope it's clear now.
Yeah.
Yes. This is 5 mm, right?
Yes.
And this is 10.
Okay. So for Q2 I got 18 times 10 to the power of 15, and for the Q1 I think that says that I got 9 times 10 to the power of 8, 9 times 10 to the power of 15 as well. So what I have to
No, you are missing something. You're not dividing it by 5 square. Okay? Uh,
uh
is it is it clear? So you will have to divide this by this square, right? And this square. Okay?
so first one I would though so the first one I would divide by like 25.
Good.
Hmm.
Let me solve it for you, right? Because
And then the next one I would do it by 10 times 10. I think that's a
first of all, my focus was not about the values, right? We will solve some of the problems, and then this problem will not be there, right? But the thing
Mhm.
that I want to explain here is, first of all, we will have to find the direction of field. Clear?
Uh-huh.
So what would be the direction of field due to q1? That
Mhm.
would be into this direction. Clear?
Yeah.
Away from this charge, because this is positive and this is also positive. So this is also going to develop. What would be the field because of this one, this q2? This would be into this direction. Okay.
Mhm. Mhm.
Yeah, so the thing that you need to understand is, if this is E1, the field due to Q1, and this is E2, what would be net field? That would be always, because they are in opposite direction. Clear? So I'll have
Mhm.
to go for a subtraction. Clear?
Uh-huh.
So this would be E1 minus E2. This must be E1 minus E2,
E2. Okay.
because they are into opposite directions. Okay. So this opposite direction term is very important when you are going to you are trying to find the net effect of both the charges. Okay. In other word, we can say that they will try to cancel them out, right?
Mhm.
Cancel out each other. Okay, but what will survive? The one who is higher than other.
Mm.
Clear? So the
Yeah.
thing is, what would be the formula for this one? That is going to be even. That is going to be 1 over 4 pi epsilon naught epsilon q1, right? q1 over r1 square, right?
Uh-huh.
Minus 1 over 4 pi epsilon q2 over r2 square. R2 square. Okay?
Mhm. Yeah.
And the value must be something like, you can take 1 over 4 pi epsilon as common from both of them, right? Because
Uh-huh.
it is available in both the parts, right? So I
Yeah.
can write q1 over r1 square minus q2 over r2 square. Okay?
Yeah.
And this is going to be 9 multiple. I hope my writing is clear here.
That says 9, right? On the 1 over
Yeah, by replacing 1 over 4 pi epsilon. Okay,
okay.
I'll have to put 9 multiplied by 10 over 9, 10 to the power 9.
Mhm.
Okay,
Yeah.
and this is q1 over r1 square. What is the value of q1? That is 10 power minus 6. Okay,
Mhm.
and what is r1? The thing is, everything that you are going to write must be in SI units. Clear?
Uh-huh.
So you
Mhm.
will have to convert this mm into meter. Okay, what would be 5 in meter? You will have to write 5 multiplied by 10 power minus 3 meters. Clear? I hope it's clear.
Uh-huh. Yeah.
Good. So I'll have to write 5 multiplied by 10 power 3 whole square
Uh-huh.
minus, and that was 2 multiplied by 10 power minus 6. Clear?
Yeah.
Oh, divided over or divided by, and this distance is 10 Clear?
Mhm.
10
Yeah.
can be written as 10 multiplied by 10 to power minus 3.
Mhm.
That can be 10 power minus 2 meters. Okay, that would be
Uh-huh.
10 power minus 2 meter. So you will
Mhm.
have to write 10 power minus 2 square. Clear?
Mhm. Yeah.
So you will have to calculate this amount. Okay.
Mhm.
Um, this I'm removing this one. Okay, so that I can write it better. I hope it's clear, right? So now the value would be, the final value would be 9
Mhm.
multiplied by 10 power 9. This is 10 power minus 6 over 25, 10 to power minus 6. Clear?
6. Yeah. Mhm.
Minus 2 multiplied by 10 or minus 6, 10 to power minus 4. Clear?
Mhm.
So what would be the final value? That would be 10 power 9 multiplied by this will get cancelled out by this one. Okay,
Okay.
that would be 1 over 25 minus 2 multiplied by 10 power minus 6 plus 4. Okay,
Minus 2. It'll be
minus 2. Clear?
yeah. Mhm.
That is going to be what? That's going to be
Yeah, I do have one question.
what? Okay,
How come you didn't write for Q1 1 times 10 to the power of negative 6?
that was 1 times 10 to power minus negative 6, right?
Okay.
1 times 10 to power minus 6. Okay,
Mhm.
usually you don't need to write 1. If
Mhm.
you are multiplying something with 1, clear? Usually we don't write. Suppose I have a number 5. This can be written as 5 multiplied by 1. But usually
Mhm.
we don't write 1. Clear?
Yeah.
This can be written as 1 multiplied by 10 power minus 6. Clear?
Mhm. Yeah.
So here what you are getting, I'm saying that 10 power minus 6 gets cancelled out by 10 to power minus 6, right?
Yeah.
That would be 1 again. Okay, so that's why I was not writing
Yeah.
that. Okay,
Mm-hmm. Yeah.
what would be the value of 1 over 25?
1/20.
5, that would be 0.04,
0.04.
right? Not 5, 4.
Yeah.
Clear?
That's what I said. Yeah.
Yeah, okay, that's good. And what would be this one? 2 multiplied by 10 power minus 2. Clear?
Yeah. Clear.
That is also going to be 0.02. Okay,
Mm-hmm. Yeah.
the final answer must be 0.02. Okay,
Mm-hmm.
0.04 minus 0.02 is 0.02, and
Yeah.
that would be 9 multiplied by 2, 18 multiplied by 10 power 9 minus 2. Clear?
Yeah.
So that would be 18 multiplied by 10 power 7, or you can write it 1.8, 1.8 10 to power minus 10 to power 8. Clear?
Yeah. Clear.
I hope it's very clear.
Yeah.
But this is one of the type when when the fields are into opposite direction. Clear?
Mm-hmm. Yeah.
Suppose first charge is negative and second is positive. What would be the case there?
Oh wait, what'd you say? I'm sorry, I didn't pay attention for a minute.
It's okay. Actually, if first charge is negative and the second one is positive, what would be the condition then?
First charge is negative at first, and the second charge is positive. Wouldn't they
Yeah.
both cancel out?
No, 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 no. They're not going to cancel out. You can see both are positive, right? In that case, they are
Oh, you
trying
said
to.
both are positive. Is okay. I thought you said one was negative and one
No,
was
no, no. I'm talking
okay.
about this case when both are positive, right? They are
Mm-hmm.
getting a subtraction. Clear?
Yeah. Yeah.
So if both are positive, in that case, they will try to cancel out each other. Okay?
Uh-huh.
But
Yeah.
suppose one is negative, Q1 is negative,
Negative.
and Q2 is positive. If Q1 is negative,
Mm-hmm.
right? And Q2 is positive.
Mm-hmm.
Is it clear?
Clear.
What would be the direction of fields at this point?
If one was negative and one was positive, right?
Good.
All right. Wouldn't it cancel out basically if they're both equally like the same?
No, the thing that I'm trying to tell you here, right? The field due to Q1, the field due to Q1,
Uh
okay?
huh.
What would be the direction of that field? It would be towards Q1,
Uh huh.
isn't it? Because
Yeah.
it is negative. What would be the direction of field due to
It would
Q2?
be on the right, the opposite of the.
No, no, no. That would be away from Q2 because Q2 is positive.
Okay. Are you? Oh, okay. I get it now. I thought you were talking about. I thought you were saying. Oh, I talking about something else. But yeah, I know where your topic now.
Get right?
Yeah.
So because of Q2, it would be opposite, right?
Yeah.
And because of Q1, it would be towards Q1. So what would be the net amount of field? That would be E1 because they both are into same direction.
Uh huh.
They both are into same
Same
direction.
direction.
So you will have to add them. You will have to add them.
Add.
Clear?
Mm-hmm.
So there would be sum of both of the fields,
Mm-hmm.
isn't it?
Yeah.
I hope it's clear now.
Clear.
Good. So what you need to figure out that what is the direction of field. Okay.
Mm-hmm.
Based on that, we can find the net or equivalent amount of the field. Okay.
Uh huh.
The total effect will be measured only by identifying the direction of fields. Okay.
Uh-huh.
Okay. This is these are very basic things. Clear?
Mm-hmm.
So simply, you will have to identify. Clear? But
Clear.
suppose the case is little different. Just a minute. If I'm saying that I have a charge minus q, I have another charge q here. Okay.
Mm-hmm.
What would be the effect of their fields on this point?
Mm-hmm.
For that, you can see the direction of field would be what? Towards minus q, right?
Yeah.
So the direction of field would be this one. Okay.
Yeah.
And what would be the direction of field due to q? That would be like this, away from q, because q is
Mm-hmm.
positive.
Yeah.
Now, suppose this is E1, this is E2, this is E2.
Mm-hmm.
In this case, you can't say that they are neither in exactly opposite direction,
Mm-hmm.
neither in same direction. Clear?
Mm-hmm.
They are at some angle. They have some angular difference in
Mm-hmm.
between. Okay. What would be the sum of the fields in this case? What would be the net amount of field in this case? Clear?
Mm-hmm.
So this we will discuss in next class. Okay.
Yeah.
I think that's enough for today, because
Mm-hmm.
you need to absorb these things, right? The things that we
Yeah.
have discussed today. Okay. Don't
Mm-hmm.
worry. This is the very first class. Okay. By next
Yeah.
class, we will have better understanding about things. Okay.
Mm-hmm.
And I think by next class we will have the syllabus also. Okay.
Yeah.
So we can plan things accordingly, right?
Mm-hmm.
Do you have any doubt or something?
No.
I hope it was like a good session and you understood things very clearly.
Yeah.
Okay.
Okay. Have a good one.
Okay then. Have a great day. Bye.